Tennessee's at-home learning series for math. Today's lesson is for all our sixth graders out there. All children are welcome to tune in. This lesson is the 13th in our series. My name is Reggie Cruz, and I'm assistant principal here in Tennessee Schools in Rutherford County. I'm so excited to be your teacher for today's lesson. Welcome to my virtual classroom. So if you haven't seen any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back and look at previous lessons since we may be talking about things previously learned today. So today, we will be learning about representing and graphing ratios in mathematics. Oh, wrong way. So before we begin, to participate fully in today's lesson, you will need paper and pencil and graph paper if you have it. Y'all ready? Let's begin. All right, so use the words, expressions, and equations from the word bank to complete this graphic organizer about our study of ratios. I'm going to give you some time to fill this out. All right, so using again the expressions, the equations, and the words from this word bank, we're going to go ahead and start filling in. So the first thing I'm going to fill in is a blank is a relationship in which for every blank of one quantity, there is blank of another. So this is a ratio. Is a relationship in which for every x units of one quantity, there are y units of another. Good job. So let's look at our facts. Our facts say ratios are considered to be blank if they are expressed in the same blank. So ratios are considered to be equivalent if they're expressed in the same relationship. A ratio compares two like or unlike quantities by division. And ratios can be shown visually using a graph or a ratio table, which we've been working with. So some examples of ratios. 3 cats to 5 dogs. 7 to 11, and x over y. So everything else is our non-examples. So $4 times b, and 2 plus 4 equals 5 plus 1. So let's jump in and get started. You notice that we mentioned graphs in our introduction. Today we are going to build on what we've learned in previous lessons to connect equivalent ratio tables and graphs. So how can we use tables and graphs to show equivalent ratios? Keep this question in mind as we move through the lesson today. We're going to build on our understanding of how to plot points in a coordinate plane using information from tables of equivalent ratios that we have seen and learned about in earlier lessons. Y'all ready? Let's get started. Our problem says Ellen is shopping for supplies at Jake's party store. Make a table to show how much Ellen would spend to buy 3, 6, 9, or 12 balloons. Then plot the pairs of values in the coordinate plane. Use the ratio table and the graph to find the cost of 18 balloons. So we're going to have to use a ratio table and a graph. So what is the problem asking us to do? Again, it's asking us to make a table, plot points, and use a graph. That is quite a bit of information to do for one problem, so let's think of how we should begin. How should we begin? Correct. We've been working with tables for the last few days, so let's start with a ratio table. How can you make a table of equivalent ratios? I agree, we need two pieces of information from our problem. So what information are we given? Yes, we're given the number of balloons that Ellen wants to buy. What else can we find? You're right. We're asked to find the cost of balloons. So now we're ready to make our table. Since Ellen is buying 3, 6, 9, or 12 balloons, we can start with a 4-column table. We will then decide if our table provides all the information we need to solve the problem. So here's our table we're going to work with. I'm going to give you some time. I want you to write it out. Does this table give us enough information to solve the problem? Not yet. So now, what is the ratio of balloons to cost? Yes, our ratio from balloons to cost is 3 balloons to $2. How can we find the cost of 6 balloons now? Right, since we multiplied the number of balloons by 2 to get our new number, our new term, we also doubled the cost. So I can multiply this by 2. So I'm going to multiply this term by 2. 2 times 2 is going to give me what? $4, which is good. Again, which means we're doubling the cost. Since we have worked with tables for a few days now, I will give you some time to complete the table for equivalent ratios. Great, let me start filling in, and I want you to check your table with my table. How'd it look? All right, you did great. Now, do we have the information we need to solve this problem? Almost, but not yet. The problem is asking for the cost of 18 balloons. So how can I extend this table to show the cost of 18 balloons? You're right, so let's extend our table. So I'm going to move this over so we can work on extending our table. So we're going to go from if I keep applying my same pattern, this will be 15, this will be 10, this will be what? 18, and this will be 12. So now can we see the cost for 18 balloons? Correct. According to our table, 18 balloons will cost $12. So what does the problem ask for next? Correct. It does ask for us to plot the pairs of values on the coordinate graph. How can we do that? Correct. First, we need an X and we need a Y. So let's determine which one of these is going to represent our X and which one of these is going to represent our Y. So you might remember that we did spend time working on independent and dependent variables earlier in the school year. By definition, the independent variable causes the dependent variable to change, while the dependent variable changes in response to another variable. Our X value is our independent variable, while our Y value is dependent variable. In our given problem, which set of values in our table do you think are the independent values? Either the number of balloons or cost. Yes, the number of balloons is our independent variable. So I'm going to make this our independent variable to show this as our X. So then that means the cost of balloons is our dependent variable, which would be our Y. So now we can pull out our values from our table to write our ordered pairs. So our first value is going to be 3, 2. Our second one is going to be 6, 4. Our third would be 9, 6. Our fourth would be 12, 8. Our next one would be 15, 10. And our last would be, what was it? 18, 12. So now that we have our points, now we're ready to draw our coordinate plane. Get some paper, get some graph paper if you have it, and let's plot these points. If you don't have graph paper, it's okay to do a rough sketch of it. And remember, since it's a rough sketch, it may not be perfect. So grab your graph paper. I'm going to rewrite these in black so we can go ahead and see it on our graph. Now that I have my coordinate plane, I'm going to make my X and my Y axis. So this is going to represent my Y. This is going to represent my X. Good job. Now I'm going to label each axis. So I know my X is going to represent what? My number of balloons. And my Y-axis represents the cost in dollars. So now I'm going to label 2, 4, 6, 8, 10, 12, 14, 16, and 18. I'm going to do the same thing here. 2, 4, 6, 8, 10, 12. So now I can go ahead and start plotting my points. So my first point that I'm going to go do is 3, 2. So I'm going to go over to 3, up to 2, plot my first point. So now I'm going to plot the rest of the points, and I'm going to go all the way up till I get to 18, 12. So I want you guys to go ahead and start plotting, and I'm going to plot along with you. So my next one is going to be 6, 4, then 9, 6, 12, 8, 15, 10, and 18, 12. Oh, did I go up too far? Went up too far. So we're going to pretend like that was not there. So now I'm going to connect my line. And notice I'm going to use a dashed line through my points. This helps us to see the pattern and also shows us that the whole number answers as pointed in the line. The points on the line between the graph points do not make sense in this situation. So, because we won't have a fractional or decimal parts of a balloon. So I'm gonna use a different color so we can see it. Use blue. Blue's my favorite. So what cost of balloons is paired with the number 18 balloons? So number of 18 balloons, what cost is paired with that? So if I go up, grab another color, go up, $18, go over 12. So 12 shows that cost. So the cost of 18 balloons is $12. So now I want to see if you understand. So let's try another one together. I want you to complete this table to show equivalent ratios representing a cost of $8 for every 3 boxes. Then write pairs of values to go on the coordinate plane, to be plotted on the coordinate plane. I want you to go ahead and complete this table. We'll check our answers in a second. We've been spending a lot of time on ratio tables, so I know you can do this to create these equivalent ratios. So I want to see if you got the same values as me. So I have ratio 12, 32, 15 to 40. So now we can start creating our ordered pairs from this information that we have. So my first ordered pair 3 to 8. So that'd be 3. My next, 6, 16, 9, 24, 12, 32, and 15, 40. So now we know we could graph them, but the question only asks us for the points. So we're only going to identify the points. And we got to make sure we pay close attention to what the problem is asking us to find. We will keep working with ways to represent ratios in tables and graphs. So as we continue to work with ratios, table graphs, we have another strategy that may help us. We can use repeated addition. Repeated addition is a strategy you use in lower grades to discover and understand multiplication. Remember that? So I can't wait for us to see how we can use it to connect to ratios. So let's dive in. Here's my next problem. All right, so our problem reads, Jack is making juice. He has 25 celery sticks. If Jack uses all 25 celery sticks, how many apples will he need to make the juice? So here's our table. I'm gonna give you a second to draw this table and write this table down. So we know that we're given the ratio table. We want to see if we can discover the pattern using repeated addition. Let me show you how. For each row in the table for celery sticks, we see that 5 is added to the number of celery sticks. So we see 5 is added here, and I'm adding another 5 here. That's my pattern. For each row in the table for apples, we see that 2 is added to the number of apples. So I see that I'm adding 2 here. If we continue this pattern, what would our table look like? Well, it should look like this. I'm adding 5, adding 5, so adding 2, adding 2, adding 2. So our table should look like this. How can we use this information to help us with our graph? Let's plot the pairs of values on our coordinate plane. What will be our x-axis? Correct. Our x-axis should be celery sticks. What about our y-axis? Correct. Our y-axis will be apples. So if I were to draw or graph this information, I know that this is my celery, and this is my apples. What can I scale my x-axis by? Correct, I should go by 5s. So I'm gonna go so that's gonna represent 5, 10, 15, 20, 25. What about our y-axis? What should we scale that by? 2s, correct. So I'm gonna do so I'm gonna write 2, 4, 6, 8, and 10. So now let's start plotting our points from our ratio table. So going back to my ratio table, I know my first point is what? 5, 2. My second point would be 10, 4, third, 15, 6, fourth, 28, and 25,
10. So let's start plotting them. So my first point, 5, 2. Go over to 5, up to 2. My dot. 10, 4. 15, 6. 28. And 25, 10. Remember, yours can be a rough sketch if you don't have graph paper. You see my graph paper is coming up off my page here, but it's fine. It can be a rough sketch. But I wanted to, it should look close. And our goal today is just to see the relationships in graphs to our tables in our ordered pairs. So your sketch should work great. So does yours look like mine? What do you notice about the graph of ordered pairs? So what do you notice about this graph of ordered pairs? Yes, they form a line. We will again draw a dashed line since the numbers in between the whole numbers don't make sense. So here we go. So let's look at this pattern using repeated addition to see if it still works out. So from 0 over, I go over 5, but I'm also going up 2. From here, I'm going over 5, because it's from 5 to 10, our scale, remember, up 2. Same thing here, over 5, adding 5, up 2, adding 2, over 5 to add another 5, up 2 to add another 2, add 5, add 2. So the repeated addition actually works for this graph. Isn't it crazy how it all comes together? Let's try another one. Y'all are doing great. Here's our next one. Suppose you read 4 pages every 3 minutes. How would you use repeated addition to make a table of equivalent fractions? So I have a table here to get us started. Where should we begin? Yes, we can look at the number of pages read, which is 4, to our time, 3. So what number of pages read will we add each time to this 4? Correct, we can add 4 since that's the number of pages we read. So I can add 4 each time to get the number of pages read. What about the number, how much we're going to add to our time? I can do 3 for our repeated addition. So let's fill in our table. That'd be 8, 12, 16, and 20. This will be 6, 9, 12, and 15. Good job. How did you do? I think we're ready to practice on. Did you notice how we used the ratio tables of equivalent ratios from the previous lesson to create a graph? I hope you saw how the graphs were a great way to represent the ratios. Graphs are a way for us to see patterns and see where our solution paths are going. So let's practice one together. I want you to make a graph that illustrates the equivalent ratios shown on the table. So go ahead and make a graph that represents this table. So since we're asked to make a graph, what are the points that we will be graphing? Correct, so I should be graphing 2, 5, 4, 10, and 6, 15. What do we need to do to get our coordinate plane ready? Yes, we need to label the x-axis and the y-axis. So make sure you're labeling your x-axis and your y-axis. We can use the scale as given in our table. So the scale for this one is going up by 2s, and the y's is going up by 5s, if you wanted to use that scale. So I want you to graph, and then I'm going to show you my graph, and then we can compare. So here's my graph. I use the scale of 2s for both. Actually, I'm going to pull it so we can still see our ordered pairs. Does your graph look similar to mine? Good job. Let's do one more together real fast to make sure we have this. So we're going to complete this table using repeated addition. Then determine what each label should be on the coordinate planes along the x-axis and plot the pairs of values on the coordinate plane. So I'm going to use repeated addition to solve this. So since this is going up by 2s, I can do that to complete my table. So I'm going to add 2 each time. It's going to be 2, 4, 6, 8, 10. This is going up by 3s. I'm going to add 3 each time to get 6, 9, 12, and 15. So now from this table, I've already started my graph. Because I can see my x is going by 2s, I already labeled my x-axis by 2. My scale is by 2s. What should my scale be for my y-axis? Looking at my table. Correct. I can make this go by 3s. 3, 6, 9, 12, and 15. So now, what does the problem ask us to do? It asks us to plot these pairs of values on the coordinate plane. So now I can go ahead and plot them. I know my first is 2 what? 3, 4, 6, 6, 9, 8, 12, and 10, 15. And then I'm going to dash because the between numbers right now does not matter in our problem. Does your graph look like mine? Or very similar? Remember, this is a rough sketch.
Great work. Today we reviewed ways to represent in-graph ratios. I hope you're seeing some connections to using the coordinate plane in independent and dependent variables. You sure did do a great job. After the video, you will have some problems to practice on your own. I will show you the independent practice problems now, or you can find them on the Tennessee Department of Education website at www.tn.gov/education. Good luck, and thank you for hanging out with me today. Listen, I have enjoyed reviewing, representing, and graphing ratios with you. Thank you for inviting me into your home. I look forward to seeing you on the next lesson in Tennessee's At Home Learning Series. Goodbye.
We know this year didn't go according to plan. Life occasionally springs a pop quiz on you, but you passed the test. Your family is proud of you, and Tennessee is proud of you. This year may have been different, but you met the moment and graduated. And we, at the Tennessee Department of Education, want to spend the next few weeks celebrating your accomplishment. Congratulations, class of 2020.